Hello there from Stuttgart. Today it's another episode of M.I.N.T, and today I will talk about historic things.
M.I.N.T. Material Innovation Nanotechnology Talk. Yip, 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 yip.
Before I start, it's time to check my BGG. Yes, my number of followers is slightly increasing, but the slope is going down a bit, I think. In contrast to this, Bill Gates is catching up again, so he's winning followers a lot. And the distance, probably you know it, is quite big, unchanged. Maybe I need to change the scale. Okay, now we like to go back in time a bit. I think it's 3 years, and I was invited to give a talk at the M.I.N.T conference, which is super important for carbon nanotube applications. And this conference was supposed to be held in Shanghai, and due to many reasons, I was not able to travel to Shanghai. And the marketing department of Fraunhofer IPA was so kind to make a video from me talking in 7 minutes about carbon nanotube application and our history and what I think is important and what is not important. So my recommendation is take a big cup of coffee like this and try to enjoy the next 7 minutes.
Ni hao. Today we have a unique constellation because we are celebrating innovation in form of carbon nanotube material, which is a very unique material, and I think it will have a prosperous future. And the venue of today is held in Shanghai, which is probably one of the most important centers of innovation. Please let me shortly introduce myself. My name is Ivica Kolaric, and I'm working since more than 15 years on applied carbon nanotubes. We had more than 400 industrial projects and probably one of the largest research groups in the field of applied research. We have many consultancy jobs and advisory jobs all around the world, and we are transferring carbon nanotube technology into the industry. Let me briefly introduce our department. We are starting from functional materials, from synthesis and functionalization, and going downstream down to the application, what helps us to transfer technology very fast. You can see on this chart that we have a couple of innovations already. We made a cellulose paper composite, polymer composite like PA, ABS, and others, metal composite and ceramic composites. I'm a member of the Fraunhofer Society, and Fraunhofer Society is one of the largest research societies in applied research with around about 25,000 researchers in Germany, but of course we are working all over the world. We are following our customers and seeking to collaborate with the best partners in the world. But now let's come to Stuttgart. Our institute is located in Stuttgart, and if automotive industry is the engine for Germany's economy, then Stuttgart is the fuel of this engine. If you take a circle of 200 kilometers around Stuttgart, you will find 80% of the entire German automotive industry within this circle. So this means when you're going outside of Stuttgart, every second person you meet is working for the automotive industry. And ever since, automotive industry was a driver for innovation. And this leads to the point that the country where we are living, Baden-Württemberg, is the number one country in economical growth, in R&D intensity, and of course in patent applications. So this means we innovate since decades. But our Prime Minister, Mr. Kretschmann, said we have to transfer from automotive country number one into mobility country number one by focusing on emission-free, autonomous and connected cars. I'd like to show you what are the challenges and the solutions for automobile production in the future and what is the relationship to nanotubes. First of all, automobile production is very complex. It used to be that you order one type of car, like the Thin Lizzy or the Volkswagen Beetle. But now today, the variants are much higher, and so the complexity is much higher. As a result, we have to find new ways how to produce cars, and one way will of course be the agile production and the usage of multi-materials. In the agile production, there will be robots collaborating with robots, robots collaborating with people, and people turning into robots. And from material side, we will have fiber integration in all parts of the car of the future. Now let's go to the point of the energy storage systems. We are talking about electro-vehicles, and you surely are aware about the roadmap of electro-vehicles of many OEMs in the world. So this means we will have a large number of electro-vehicles on the market. And here one key technology is of course the battery. And within the battery we have one challenge. You cannot scale up the benefits of the learning curve to the price of the battery. So this means we have to find new ways and new kinds of producing battery materials. Yeah? The other thing is connectivity. You're surely aware about the Internet of Things. Everything will be connected, and the car will be connected too. It will be simply another thing into the Internet. The car will communicate with other cars, with people, with passengers, with building and parking lots. This leads to the point that in a couple of years every car will be connected. We are assuming that 100% of all cars will be connected cars, which requires a lot of sensors. When we conclude this or compile this future perspective, we know we have to change our production, we have to make lighter cars, and we have to find new energy storage systems as well as new communication systems for human-machine interface. And this all leads to a higher demand on functional materials for better electronics. Simply, if you see this picture, you can see that in the car of today we have a couple of sensors like approximation sensors, collision sensors and other sensors, and all these sensors need to be protected against electromagnetic waves. So we are expecting a high demand for electromagnetic absorption and electromagnetic protection. And here is the first, let's say, low-hanging application for carbon nanotubes. You can produce conductive films and conductive papers to protect your environment against electromagnetic waves. The second thing is batteries. Within batteries we produce carbon nanotube enhanced batteries which used to be integrated into car bodies, or we replace the binder by carbon nanotubes. By replacing the binder by carbon nanotubes you can save energy and improve the battery performance. Secondly, we like to reduce weight, and by improving aluminium alloy with carbon nanotubes we can increase the tensile strength and increase the ductility quite a lot. So this means we can make a high performance aluminium alloy which makes cars lighter and safer, or we can reduce friction by using carbon nanotube in copper bearings. The other thing, we can increase comfort. Using carbon nanotubes we can produce electrical heating elements for electro vehicles to increase the comfort in your cars. Or we can even change the color. If you see this slide, you can change like the car color, the car paint shop will change from red into transparent. And today we can change already 3 colors. So this means by using our technology, you can change the color from your car on demand. Other applications what we are working is to use the whole car paint job as a sensor. And we integrated carbon nanotubes into the car paints, and we use the car paint as a sensor. And you can see on this movie how you're touching the car paint, and you can use this as a touchscreen or a stretching sensor. So you saw that from the future's most wanted technology like antenna, sensors, energy storage, data storage, carbon nanotube plays a significant role in that. And multi-wall carbon nanotube, which is a commodity product, can fill this gap in some cases, but unfortunately is not conducted enough. And let's go back to 8 years in time. I had a seminar in Tokyo in 2010 and we talked about the future of carbon nanotubes. And one message was very clear, that in automobile production the margin is very low. So this means the benefit is supposed to be very high and the cost should go very down. And at this point we saw that the future of nanotube will be a single wall carbon nanotube future. Because most of the application which are really valuable to change requires high conductivity, which only single wall nanotubes can provide. This brings me to my conclusion that the digitalization will change everything, and we will have a big demand and rising demand for new materials such as carbon nanotubes. And the production of single wall carbon nanotubes will help us to really fulfill this demand with a couple of new good products. And so this is what I'd like to tell you, and thank you very much for your attention. Zack.
I hope you didn't fell into sleep because it was too long and maybe too boring for you. But if I see the movie, would I make it the same? I don't know. But in general, the key messages are true. So I really think that nanotube is a good candidate for many applications, and you will see nanotube in many applications, which are important, like batteries and others, and lightweight materials. So I think is quite okay this presentation, even though that probably it was the longest 7 minutes in your life. Nevertheless, I hope you enjoyed it, and next week I will back again with a bit more science. So take care, bye bye, have a great week.
M.I.N.T. Material Innovation Nanotechnology Talk. Yip, 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 yip.